Converting to vertex forms. So this is the easier. This is the easier of. This is not the easier. This is the harder of the two ways of converting. Converting to vertex form, I think, is harder than converting from vertex form. That's why we're going to talk about it first to make sure you guys understand this. Your homework is a little bit longer tonight and a little difficult, so I will be doing some problems from the homework. So if you take good notes, you may notice, hey, I already did this one, and you can just write the answer, right? Or write like in notes or something like that on those problems. Okay? So here's an equation that is in whatever we want to call this, standard form. Oops, that's not an equation. This is an equation. If we want to convert this into vertex form, first of all, let's remember what vertex form looks like. Y equals, you guys have it there? What is vertex?
It's a times x minus h squared plus a.
So we need to get, this is the tricky part, right? This x minus h squared. We need to get a perfect square somehow out of these first two terms. Now, occasionally, the entire thing already is a perfect square, which is awesome. But is this a perfect square? So basically what I'm asking is the square root of 17 half of 16? The answer to that is no. So we have to go back to something that you guys probably learned last year, completing the square. Okay? But we're going to do it a little bit differently. So I have y equals x squared plus 16x plus something is going to give me a perfect square. So I have to figure out what is going to give me a perfect square here. And the answer is always half of this squared. So half of 16 is 8. 8 squared is 64. Can I just add 64 to my equation? No, totally not. I just completely changed the equation. So what I'm going to do, I add 64 here. Over here, I subtract 64. Okay? So this compensates for this. So now I just added 64 and subtracted 64. Effectively, I added 0. Is that okay? Yeah, it's okay to add 0. So 64 is half of 16 squared. And you'll see why I did that in a second. Okay? So now the next step, you have to figure out a perfect square for these first 3 terms. So the perfect square here is x plus 8 squared. That looks a lot like vertex form. Okay? And then over here I have plus 71 minus 64, so I have a total of plus 7. And that's vertex form. I found a perfect square here, and my constant changed over here. They're kind of common.
What happened to 71?
The 71 minus 64 became 7.
I get it.
Yeah. So we're going to do a bunch more. This is kind of the general idea of what we're doing. And I'm going to tell you the steps, now that you have sort of an example in your head. step one we didn't have to do in this problem. Step one, in general, you want to make sure the equation is in standard form. Occasionally, you'll see an equation that has like y plus x equals x squared minus 2. Right? The first thing I would do here is subtract the x over to make sure that that's in standard form. So if I have an equation in standard form, step 2, which we also didn't have to do here, we're going to factor a out of the first 2 terms. Okay, we didn't have to do this in this case because a was 1. But we'll do an example like that in a second. Yeah?
Doesn't it have to be, okay, so on the first example, it's x plus 8 squared. Doesn't it have to be x minus 8?
Right. So in this case, h is negative 8, right? So our vertex would be negative 8, 7.
And also, are we going to have problems that aren't standard form on our homework?
Wait, I just have a quick question. What happened to the 16?
So I could FOIL this out. I'm going back here. X times x is x squared. X times 8 is 8x. 8 times x is 8x. 8 times 8 is 64. 8x plus 8x is 16x. So this is this. Okay. Step 3. And this step I'm going to kind of simplify because we've done completing the square before, but you may want to write a little bit more in your own notes. So I'm just going to say make the first 2 terms perfect square. By adding a constant. By a constant, I mean like a number with no variable. And then I'm going to say also subtract the constant from the, I'm going to say from the end, because like here we put it over at the end. Okay? I could say subtract it from the third term or from the other constant term, but I just think if you remember to stick it at the end, it'll be good. Yeah.
Okay, so you said sometimes we'll have like y, like you will have the x on the other side or something. So if you like make it into standard form and you end up getting y equals negative x squared plus 16x plus 71, would you factor out the negative 1? And then just do it?
Yeah, whatever a is, if it's not 1, whatever a is, if it's not 1, you have to factor out. So if it's negative 1, if it's 3, if it's negative 7, all of those need to be
And
factored
will we
out.
have to graph them after we change it into vertex?
No, not, well, there is some graphing on the homework, but you're not graphing the ones that you factor your perfect square, combine constants. And then you're done. Okay, let's look at an example where we have to do not all of these steps. I'm going to still give you one that's in standard form, but where we have to do step 2 at least. Yeah, so I have to factor out a. But notice I'm only factoring it out of the first two terms. So y equals negative x squared plus
I feel like we'll be
14x.
outside. Grab like
I'm going to leave a space there. And I'm keeping the minus 59 out of the parentheses. I'm not factoring negative 1 out of that. Okay? This is going to be important in the next step too. So that's step 2. Step 3, I'm going to make these terms into 3 terms that are a perfect square. So I have to add half of 14 is 7. Squared is 49. What did I actually just add to this whole equation? I added 49 here,
So you have to subtract 49.
but this 49 is affected by this negative. So I actually added negative 49.
You need to add 49.
So now I need to subtract negative 49. I need to add 49. So even though this looks the same as this, it's not, because this affects this. So if there were a 2 out here, what if this said 2 times all of this? That would mean I didn't actually add 49, I added 2 times 49. You guys see that? So whatever I add here, I have to remember to multiply it by this before I subtract it over here. Okay? So be careful about that. If you want to kind of check your work at this point, what you could do is kind of a check, is just use your distributive property. So I'm going to say negative x squared minus 14x minus 49 minus 59 plus 49. And now that I've distributed, these should look like opposites. So I can kind of use this step to check myself to make sure that this is the opposite of this. Okay. But this is the one that I actually am going to factor. So y equals negative. Inside the parentheses, I want to turn this whole thing, I want to factor this as a perfect square. So I know that that's going to be x plus 7 squared. Over here, I'm going to combine the minus 59 with the plus 49, so I have minus 10.
And that's it.
And that's it. That's Vertex 1. So this step is just to kind of check to make sure these are opposites. If you're ever confused, like, wait a second, it's plus 49 and plus, it seems wrong. Just distribute it and see if they're then opposites. It will always work. Okay? So it's a good step to check your work. All right. Questions about that one? Let's go to another example. So I'm going to leave the steps over there. Let's do this example. Y equals 2x squared plus 8x. All right. This one's a little funny because there's no
C.
C. C is 0. Okay, I'm still going to do the same thing. Is this in standard form?
No.
Oh,
Yeah. It says y equals. That's really what we're looking for. And then these are in order. Okay. I'm going to factor a out of the first two terms. So I have y equals 2 times x squared plus 4x plus 0. Right? There's no other constant. Oops. I want to leave a space here as I write this so that I can complete the square. What number here will make this whole thing a perfect square? Plus half of 4 is 2. 2 squared is 4. Okay? So you can even do this over here. Half of 4 is 2. 2 squared is 4. I would love to see this on your papers when you do your homework tonight. Because it shows me, okay, you actually thought that through. You're taking half of this and squaring it to get that. What did I actually just add? I actually just added 2 times 4. So I added 8. What do I have to subtract over here? I have to subtract 8. Okay, if you don't believe it, just do this. Y equals 2x squared plus 8x plus 8 minus 8. And then those look like opposites. Right, so all I'm doing is distributive property. 2 times x squared is 2x, 2 times 4x is 8x, 2 times 4 is 8, and then minus 8 makes sense. Okay, now going back to this one, y equals 2. What is the perfect square version of this? Well, if you did your work over here, then you know already that it's x plus 2. And I'm done. So there's sort of like, when you don't have a c, there's sort of one less step, because you don't have to combine the 8 with whatever was already there.
Would
Yeah.
it always be half of the, well, for the final equation, I noticed that with, what is it called? H is always half of where you got your square root from.
Yeah.
So is that always?
Yeah, h is always half of b, right? Yeah. That is not always true. It's always true once you get to this step, right? But it's not half of this, right? Because if I have to factor out an a, then it changes to b. Does that make sense? So it's half of b divided by a,
Okay.
which should sound kind of familiar, right? b over 2a, doesn't that sound kind of familiar? That's our h. Oh yeah, h is the negative of b over 2a. Oh. Right, that's what h is. Okay. Alright. Let's do an example that's weird. Just because it's good to see weird stuff and say, hey, I can do this. Alright, what if you had something like this? 1/2 y plus 4 equals x minus 7. I'm going to tell you that my step 1 here is not always the best advice in some sense. So let's watch how we could do this. I want to get y equals. That's really what step 1 means. I want to try to get y equals. So for now, I'm not going to worry about this side. This side looks weird. But it actually kind of looks like vertex form, doesn't it?
Yeah.
Yeah.
But can you just like find a way to make it vertex form instead of
Right.
a way to make it standard
Exactly. So I don't really need to make it into standard form. What I'm trying to do is have y equals on one side. The reason that I said this is because if I had like y equals x minus 3 plus 5x squared minus 10x, then the rest of these steps don't make sense. Okay? But there are times when making it into actual standard form is not helpful. So what I'm going to say is first get the y equals, and then rearrange the x things in the correct order. So how would I get y alone here? What's in the way of y? Okay, I could totally distribute the 1/2, or I could just multiply by 2. 2 times 1/2, and then 2 times this. So what is 2 times 1/2 of y plus 4? It's just y plus 4. And I no longer really need my parentheses. And then what is 2 times this? It's just 2 times this. Right? What else is in the way of y here? How do I get rid of plus 4? Minus 4 from both sides. 2 times x minus 7 squared minus 4. Okay, now I better get this in the standard form, right?
That is standard.
Yeah, that is a vertex form. I'm not going to go all the way back to standard form and then do all of this. This is vertex form. Right? So just by isolating the y, I put it into vertex form. So that's why I'm saying, make sure equation is in standard form if you're going to do steps 2 through 4. In this case, do I have to do steps 2 through 4? No. So I would say first, y equals. So the first thing I want to do is just get y equals whatever. Then, if it's not already vertex form, or if you don't see an easy way to make it into vertex form, then you need to put it all in order in standard form. Okay? Do you have a question?
I did.
Okay. You don't have to ask it. I won't be offended. All right.
I did, but I forgot it.
Oh, yeah. Okay. Let's do one more. 6, okay. So first thing I need to do here is get standard form. So I'm going to get y equals, right? Okay, I could subtract y, but then I'm going to have negative y.
But then you can multiply everything by -1.
Okay, yeah, so that's one way of thinking about it. I would just think about it as subtracting everything else. So then I have y alone equals negative 6x squared minus 12x minus 13. Is there anything that I need to rearrange here before I start step 2? No, I have x squared x 13. There's nothing that can be combined or reordered. Alright. I have to factor out a from the first 2 terms. So I have negative 6 times x squared plus 2x. Negative 6 times x squared makes negative 6x squared. Negative 6 times positive 2x makes negative 12x. I'm going to leave myself a space, and then I just leave the minus 13 as is. What is half of 2? 1. Right, half of 2 is 1. 1 squared is
1.
So what do I need to add here? Plus 1. Now, what do I have to subtract here? Negative 6 times 1. So I have to subtract negative 6, which is the same as adding 6. Let's just check to make sure that really looks correct. Y equals negative 6x squared minus 12x minus 6 minus 13 plus 6. So now I see that those are, really they are opposites. Okay? Now we're going to go back to this. I know that my perfect square is x plus 1 squared minus 13 plus 6, 7. Well, 13 plus 6 is 7, but negative 13 plus 6 is minus 7. And that's vertex 1. Okay, what questions do you guys have? If you think of it, you can ask it as I'm handing out the homework. Where did the mouse go?